Thank you very much. I'm just so pleased that you all came back. After all of this afternoon's sessions, it's an amazingly hard act to follow all of those fantastic talks. But first I'd like to have you take a look at these icons of Minnesota up on the screen here. When I do climate change talks very frequently, I follow people like Will Steger, who are talking about the Arctic and the ice melting and that kind of thing. But really the images that are on the screen are the ones that we in this room and the citizens of Minnesota and the visitors to Minnesota really should be anticipating. These are the endangered icons under a changing climate. So I'm going to talk tonight about climate predictions for Minnesota, climate trends for Minnesota from over the last century. And then I'm going to home in and talk about climate change impacts on aquatic ecosystems. And I'm going to draw on some data that are hot off the press, as they say, in terms of summarizing some historic data for the state. And then I'd like to very briefly talk about where we should be going from here. This is a graph that I am sure you have all seen dozens of times, looking at predicting temperature change out to the end of the century. These represent the model predictions under a number of different climatic scenarios as well as social and economic conditions. And this represents the range of the error estimates, or the range of the model estimates by the end of the century. This is the data for, or the projections for surface temperatures and precipitation projections for North America. And what I like to show people is how we here in the Midwest are sort of in a hot spot of activity, that is a hot spot in terms of warming. We also, as you would notice here in the Great Lakes region, would be in an area where we would see the greatest amount of warming for North America, or at least for the United States. Down here towards the bottom, we can see both in the winter time as well as the summertime that precipitation projections are going to be quite different. We're anticipating much more precipitation shifting towards the winter, with precipitation not being as frequent in the summer and the fall, but during the summer and the fall, predictions hold that this precipitation would be falling in much more extreme events. I'm just going to show you a downscaled projection for Minnesota. This is developed for 2039 and then 2069. And we're looking at temperatures in the range of 5 to 6, or 5.5 to 6 degree Fahrenheit increases by the middle of the century. And by the end of the century, the model predictions are really quite extreme. They could be in the range, in the worst case scenario, of around 12 degree Fahrenheit, which is quite extreme. As I mentioned before, the precipitation changes are really, we think more in terms of shifts in precipitation for Minnesota rather than changes in the absolute amount of precipitation, with greater percentage of increase falling in spring rainfall. And if you're a farmer, that is bad news. You don't want increases in precipitation occurring, the bulk of it occurring in the spring. It makes planting much more difficult. So this is a classic picture that was in a report that I was a part of writing in 2003, Climate Change Impacts in the Great Lakes Region. This suggests that climate in Minnesota is going to move towards Kansas in the summertime and more like Wisconsin, southern Wisconsin in the wintertime. Now, I don't know about you, but having grown up in Puerto Rico, Kansas in the summertime doesn't seem like a really great option At least in Puerto Rico, we have the trade winds blowing in the summertime. In Kansas, there's just lots of humidity and lots of heat. That's not what we moved to Minnesota for. At least that's not what I moved to Minnesota for. So here are some significant climate change trends that have been occurring here in Minnesota. As we all know, temperatures have been increasing everywhere, but they've been increasing in the northern part of the state, particularly the northern third, much more rapidly, and I'll show you some data there, much more at night, much more rapidly since the 1980s, and it is our minimum temperature in the wintertime that is seeing the greatest change. Longer growing season, precipitation increasing, but it seems that we're actually converging on a precipitation pattern that occurred at 100 years ago. So in a way, we are coming back and cycling in that trend. But the shorter duration of ice cover is something that for Minnesotans is going to be something of a culture shock. If we can't have ice fishing in the wintertime, that's a cultural activity that I think many Minnesotans can relate to and have as a part of their wintertime activity. Well, many of you that plant gardens know that plant hardiness zones have been changing. For instance, when I moved to Minnesota 22 years ago, it was impossible for us in Duluth, at least in my neighborhood, to grow red tomatoes. I mean, we specialized in green tomatoes and green tomato recipes. Red tomatoes are just something that we just take for granted, even in relatively cold summers such as this one. So it is very clear, at least from our personal experience, that we're seeing rather abrupt and large changes. So this is the graph from the State Climatology Office showing the trend in the northern extent of the season, the growing season length. This is 62, almost 65 days per century, but 27-day increase in the growing season length since 1980 in the north. As you can see, that in the south is much less extreme, and there's a lot of scatter around those observations. Our average wintertime temperature, as I said, is increasing, particularly in the north. It is increasing, at least since the 1980s, increasing rather rapidly. But also we're seeing this mean annual precipitation increasing everywhere across the state, with an increase in mean annual runoff, that is the water that is running off in excess. But you'll see that Minnesota is quite varied in terms of the distribution of runoff. We're a very tall state. There are conditions that change very dramatically from the northern part of the state to the south and from the east to the west. Any of you that have driven from the Twin Cities or St. Peter up to the Boundary Waters, for example, have passed through that transition zone around Hinckley, and you've noticed that the oaks kind of drop out and you start to get northern hardwoods, and the boreal forest begins north of Duluth in the Boundary Waters. Another aspect of the trends that we're seeing is this average ice out date is getting earlier and earlier, particularly in this trend over the last 20 years. Very dramatic change in ice cover. So what does this all mean to us? Climate change models and the trends that we're seeing are showing higher temperatures, increased precipitation, and an increased incidence of intense storms. Now, ecosystems are really struggling to keep up with these changes because they are occurring so rapidly. They're occurring outside the range of the evolutionary time for most of these systems. The impacts that we're predicting would include things like changes in the hydrology, changes in ecosystem structure and function, including things like winter survival, exacerbated pollution because of the intense storms and a lot of the runoff, increased incidence and intensity of fire, flooding as well as drought, because we're shifting precipitation into the spring, making the summers drier. The thing that is most important, though, is that climate change will not occur in a vacuum. We have all of these disturbances that are ongoing, and climate change will just sort of settle on top of those, and in many cases exacerbate the changes that we are seeing and the disturbances that we're seeing. For example, some of the things that we're experiencing and seeing in terms of our ecosystems are increases in summer temperature in Lake Superior. Now, this is a 3-degree centigrade increase since 1900, and if you were in the other session listening to Steve Coleman, he would probably be spending a lot of time talking about this phenomenon, so you'll have to stay here and listen to my colleague Ed, but take a look at the web-based show of Steve Coleman's talk. Now, the one thing about this summer temperature for Lake Superior is that the water temperatures are increasing significantly faster, 3 times faster than air temperatures, which is quite an interesting phenomenon. And we found that, or they found that this is all due to the fact that ice cover has been declining so dramatically on Lake Superior. So my colleagues and I have been assembling data from across the state of Minnesota dealing with all kinds of phenomenon related to water. Heinz Stephan from the St. Anthony Falls Hydrologic Lab and his student have been looking at stream flow and lake levels. What they found is that over the course of the 50-year record, looking at 5 major river valleys and 36 USGS gauging stations, that they're seeing increased peak flows. That is, the height of the hydrograph is much higher than it was previously. Also, the duration, that is, the length of these floods is increasing. And also, coincidentally, the increases in both the summer and the winter base flows, that is, the level flows that occur in between rainstorms, have been increasing over this time period as well. So in combination with the hydrologic models and the climate models, what we're predicting in terms of water levels is that the shorter duration of ice cover will increase evaporation in the winter time, and providing an open surface, that is, that lack of ice cover provides an open surface, and the differential between the air temperature and water temperature will increase evaporation, thereby lowering water levels. Warmer air temperatures in the summer will increase evapotranspiration, that is, the water that's taken up by vegetation. We're expecting to see moisture in soils drawing down, which would also draw down the water level in the water table. And the models are much more complicated and difficult, but it seems that Great Lake levels are anticipated to be much lower, especially in Lake Huron and Lake Michigan. And this is a graph showing this phenomenon by the end of the century, with Lake Superior being less affected than the lower lakes themselves. Lake levels themselves are seeing an increasing trend over the past century, but there's a lot of variability across the lake, across the state. As I said, we're a very diverse state, but we're seeing a strong trend with increasing water levels in our lakes. Well, this is a quite complicated diagram, but it's looking at the difference between evaporation or precipitation and evaporation. And so let's focus on these 2 lines down here. What this is showing is how the precipitation, evaporation are affecting lake water availability. And what I want you to get out of this diagram, which is fairly complicated, but I want you to see that the arrows are fatter in some areas, and there are stars in some areas versus others. The darker the color, the more significant the relationship, and the fatter the arrow, the greater the magnitude of change. And what we're seeing is that in the Fargo area, we're going to see much higher lake levels, or we have seen much higher lake levels. But here in Duluth, the changes are not significant, and they tend to be towards declining water levels, which is exactly what we've been seeing in our streams up there as well. So Duluth is an anomaly across the state. So in general, annual evaporation varies across the region. The peak monthly evaporation is mostly increasing, and the trend in precipitation is strongly upward, which is resulting in higher water levels. So with all of this, we're also predicting degraded water quality as a result of increasing temperatures, because it causes a stress in terms of the dissolved oxygen concentration. But there are some increases projected in terms of the production, that is the amount of photosynthesis that would take place, which is temperature controlled, is expected to increase. And of course, if we continue to add nutrients to the system, as Nancy talked about earlier today, we can see increased production that might not be so great for the system. This increase in the intensity of storm events is really of greatest concern for us from a water quality perspective, because it really points towards increased surface runoff, which brings much more sediment to the system and modifies channels in a way that is not particularly healthy for the system. This also brings this nutrient load to the system, which is what Nancy discussed earlier today. So I'm sure everyone in this room has experienced the concept of lake stratification, which is that feeling when you're swimming in the summer and you have that nice layer of warm water, but you end up sticking your feet below that thermocline, and you end up in that colder water zone. Well, this process of stratification actually locks the water down below this layer and causes oxygen concentrations to decline over the course of the summer. My colleague Ed is going to be talking about many phenomena associated with some of the processes that go on at the bottom of lakes, many of which tend to release phosphorus and other kinds of metals. So he's going to be talking primarily about things such as changes in water level and the effect of lake stratification. So in addition, I have a colleague who has a number of different sensors which he puts in streams. And one of the phenomenon that we see when we have these big storm bursts is an increase in the amount of sediment that you see coming into the system. So as the storm increases here, this blue line is the water level, and the darker area is the amount of sediment that's coming in. Now, this is a phenomenon that we've been able to record over and over again, and under these changing climatic conditions with an increase in the number of these types of storm events, we would anticipate degraded water quality as a result of that. And this turbidity is very, very stressful to fish. So my colleague Rich Axler has been looking at 630 lakes where we have at least 15 years of some water quality data. And what we're generally seeing is that where there are changes or trends in the system, those trends tend to be positive. That is, the water levels are increasing in 60% of the lakes where we have changes observed. Not only that, but in the few lakes that we have where we're seeing stability of that thermocline, that is, where the differential between that warm water layer and the cold water layer is very strong, we're seeing that particular type of phenomenon is increasing in the few lakes where we do see that particular trend. What we did see is that over the course of the 30 or so years in which we were looking at these data, that the increase in temperature has been about 3 degrees Fahrenheit over about the last 30 years. So there is a website that's available. You can all query your favorite lake. You can look at trends if they exist, and you can look at a number of different water quality variables and see whether your favorite lake is represented. And I'll give you that website at the end. Well, I suspect that many of you in the audience are interested in fishing, and clearly there are many changes that can be associated with changing climate, including range expansion, primarily because cold water species are likely to have their habitat ranges contract, while warm water species are likely to increase their habitat. So walleye, for instance, would tend to benefit, whereas things like lake trout would tend to have much less cold water habitat by the end of the century. So cold water habitat decreasing, warm water fish habitat increasing. This is the distribution of cold water fish in Minnesota. So we see burbot, lake trout up here, cisco all over the central part of the range, and lake whitefish. These are the fish that would tend to benefit from changing climate. However, we are seeing trends towards decline in cisco as a result of what we believe is warming temperatures. There's a number of different factors that influence the distribution of walleye, and many of these variables are going to be subject to the effects of global climate change. So we've been looking at many of these factors, and what we've seen is that there's a relationship between ice out and the date of spawning. So if there was a perfect relationship between ice out and spawning, we would see those lines converge. But what we're seeing is that spawning is just slightly delayed relative to the ice out signal. And since we're seeing ice out happening earlier and earlier, you can imagine that that trend, that very tight relationship with walleye spawning is also visible in the data record. We're also seeing changes in the distribution of fish species with, for instance, the smallmouth bass being much more common since the late 90s, with other species not being quite as affected. So just to summarize some of the new data that we have, we're showing that ice out dates are occurring earlier, that precipitation is increasing, lake levels are increasing, but the trends are pretty subtle. Lake water temperatures at the surface are increasing, walleye spawning is occurring earlier, and some of the fish communities appear to be changing. The question is, what should we be doing about this, particularly in light of the fact that recent observations show that emissions are just not coming down. They are at the upper boundaries of what we see the IPCC reporting, and this is, these indicators are showing this over and over and over again. What we're trying to understand is what the next steps are. This also is a graph. These are the climate projections by 2010, and this is where our emissions are, which is outside of the projected boundaries. So our emissions continue to increase despite the fact that we've known about these problems for quite some time now. So I suggest that what we need to be thinking about is a three-pronged approach to dealing with climate change. We heard the previous speaker this morning talking a lot about mitigation and some about adaptation. We already are committed to a certain amount of warming. We need to figure out how to adapt to that warming, but we also need to work very hard to reduce emissions to keep it below that critical threshold that he discussed this morning. But lastly, we need to be thinking about minimizing pressures on the environment in order to reduce the potential impacts of climate change on top of other types of stressors. So just to give you one sense of where we should go is transportation and electric power are about a third of all of our emissions. And those are the types of activities that many of us have in our power, a way to change these kinds of things through modifying our behavior. And I'm suggesting that we pick up the challenge and try and do what we can, and also encourage our communities to do the same. I had lots of help with this. There are a ton of folks associated with this project. It was funded by the Legislative Commission on Minnesota's Resources, and Ed Swain is one of the cooperators working on this project. I also would like to leave you with this website so that you can check out your favorite lake. Thank you.